Hello, everyone. Welcome to Chapter 1 and the first week of class. I'm excited to be teaching this course. Without further ado, let's jump right into it. So, kind of just a chapter preview. I'm not going to read this off, but just kind of a preview of where we're going in this lecture. So, let's jump into defining development. There's not really one definition of development, and you'll see throughout this course that there's not one real definition of anything. Different theories have different definitions of all these terms, but let's, have a operational definition so we can actually continue on with this course. So development is systematic changes in continuities in the individual that occur between conception and death. There's physical growth, cognitive growth, and psychosocial growth. And all these types of development, though, interact dynamically. So while there are individual components of development, you'll see throughout this course that everything kind of interacts with everything. It's kind of a key feature of developmental psychology. Defining development, starting with growth. Physical changes that occur from conception to maturity. Biological aging, which is deterioration of organisms that leads to death. Aging, which is physical, cognitive, psychosocial changes, positive and negative. And developmental changes involves gains, losses, neutral changes, and continuities in each phase of the lifespan. So the idea here is that typically once you reach a certain age, conventional thinking is that development consists of nothing but losses. But we'll see throughout this course that older adults have the opportunity to acquire things such as wisdom. And they also have more concrete gains, such as word knowledge. Biological aging could be thought of as just because someone is, 50 years old does not mean they have the same biological age as a 50-year-old. We know that there are certain 50-year-olds who are, running a 5K, running a half marathon, etc. While there are other 50 years olds who are approaching the end of their lifespan for a variety of reasons. Okay, let's conceptualize the lifespan by looking at age grade. What we're looking at here is the different roles and responsibilities, statuses, and privileges that certain societies grant individual depending on their age. Age means different things in different societies. Now, in contrast, we have age norms, which is society's way of telling people how to act their age, influence people's decision about how to lead their life. So, if you're 70 years old, it wouldn't be typical for a 70-year-old to participate in street racing, for example, or maybe even a 5-year-old taking calculus courses. You wouldn't expect to see a 5-year-old in your calculus course. Looking at social clock, person's sense of when things should be done and when he or she is ahead of it or behind the schedule dictated by age norms. Off-time events may negatively affect development. And obviously, this is historically and culturally based. So when someone gets married, for example, those rates change by age. 200 years ago, when your lifespan is 50 years old, for example, or whatever it was exactly, you're going to have an accelerated uh, social clock compared to a cohort with a lifespan, let's say, of 80 years old. And you'll see this over and over again, and for a lot of concepts in this textbook, they're culturally and historically based. So subcultural differences, class. Children in poverty experience more noise, pollution, crowding, family disruption, hunger, exposure to violence, and they accumulate stress. Individuals from lower income families tend to reach milestones of adulthood earlier. They're asked to grow up fast. So I'm going to use class typically in this class because in this course, I should say, because SES to me is typically poorly defined. If you look in research papers, people generally refer to class or SES as the extent to which they complete college or their parents, the highest grade of education that their parents earn. And that is a very questionable practice, especially when we know about the rates of income, for example, or the earnings and the wealth of of individuals who only had a high school degree or just an AA degree 60 years ago is radically different than it is now. So I'm going to use class and poverty instead. But the point of this slide is that individuals from lower income tend to reach milestones quicker for a whole host of reasons. Because, for example, teenage pregnancy could be earlier, dropout rates are higher, so you enter certain adult milestones quicker, and you accumulate more stress in lower classes. And we're going to get to the impact of stress, the accumulation of stress on development throughout this course. I hope I'm able to drive home the extent and the degree to which uh, poverty and specifically accumulated stress impact development. So as I alluded to in the previous slide, history matters. The five traditional markers of adulthood, look at them, I don't have to read them all off, but obviously what cohort, what era you are born into impacts when you're expected to reach those milestones of adulthood. And some people never reach those milestones of adulthood because they don't value them and they're not looking to complete them. For example, marrying and having children. And leaving home means it's completely different definitions depending on when you were born. We are now seeing multiple intergenerational homes because the life span is extended within, across the globe. For particular middle age couples or individuals, you see their parents living with them, so they're taking care of their parents and also have children at the same time. Another historical example is World War II. Jobs are more complex, require more education. So, kind of what I was alluding to before, it might have been you could make a living with only a high school diploma in a certain historical period for a lot of reasons. But we've seen wealth and income stagnation for people with lower levels of education being completed. Industrialization increased, farming decreased, labor force require new skills taught in school. So the advent of industrialization required individuals to go to more schooling, which is going to kind of delay achieving some of those developmental milestones. And even something like child labor laws, if there's no child labor laws, okay, congratulations, you've entered the labor force. You are a hardworking member of society at 11 years old. But, depending on the country, in the United States at least, we kind of that macro economic and political policy limits and change the developmental trajectory of a whole host of people just by child labor laws. Depression slash recessions, out of work, demoralized fathers, less affectionate, perform worse in school, more behavior problems. So what I'm getting at here is that global economic and political legislation and depressions and recessions have impacts on development. And this is seen across cohorts. And one example is just to the right, looking at the East Asian financial collapse, and you can see the death rates from infectious diseases and that spike once that financial crisis hit. And that's just one historical example. And you see this a lot through history. And looking domestically, you can see rates of suicide increasing, but when the New Deal began, suicide rates falling. So again, these large countrywide changes impacting developmental outcomes, in this case, rates of suicide. So finally, wrapping up historical changes, childhood. Childhood came to be viewed as different from adults in the 17th century. Emerging adulthood, defined in the late 20th century. Just basically the point here is that these definitions are relatively new, especially emerging adulthood, with the advent of 20-year-olds, 18 to and up, staying in college for long periods of time. I had the great pleasure of being in college for, I don't know, over 11 years. That is a kind of a process that was not as historically common and did not exist in many eras. Nature and nurture, like kind of a classic debate, but I want to drive home in this course that these processes, these factors, interact dynamically to create developmental outcomes. So kind of just a brief definition is how biological forces, environmental forces act and interact to make us what we are. We have nature. Some aspects of the development are inborn or innate, such as maturation and genes. Not exactly correct there, but for the purpose of this class, it's fine. But the point is a predictable process. It's a species-wide developmental trajectory that happens regardless of environmental influences. Versus nurture, change in response to environment or learning. That could be from parenting, peers, class, and by class I mean economic terms, trauma, and historical period. So what are the goals? What the hell are we doing? Why are we in this class? Why am I going to record 20 hours of lectures? Well, the goal of lifespan developmental research is description, prediction, explanation, and optimization. And globally, the point is, why do individuals develop differently than others? Let's look at some OGs of developmental psychology. Baby biographies were kind of one historical example, one of the first examples of developmental psychology research. Scholars observe the growth and development of their own children, focus on whatever the parent was interested in, not generalizable to other children. So the idea here is that you're watching your children, yeah, you're getting some kind of interesting data, especially if you know very little about how humans develop from your children, but are the circumstances of your children something that is universal across all cultures, across all historical eras? Obviously, this is going to be a kind of self-selected and biased sample and approach to developmental psychology research. The founder of developmental psychology is typically referred to as G. Stanley Hall. He kind of characterized adolescence as like this chaotic period. So kind of that framework is kind of is given birth by this individual right here, Mr. Hall or Dr. Hall, presumably. So let's look at Bolt's 7 features of developmental psychology. The first is that development is a lifelong process. Development in any period of life is best seen in the context of the whole lifespan. So kind of old school way of thinking was that development only occurs in childhood, and who gives a shit about what's going on past, I don't know, name your age, 5 years old, 10 years old, 13 years old. But now we understand that development is a lifelong process. Development is also multi-directional. Different aspects of human functioning have different developmental trajectories. Now, a lot of these will seem like common sense now, but at the time, not necessarily so. So the idea here is that just because you level up, you're now 4 years old instead of 3 years old, not every aspect of your developmental trajectory is advancing at the same level. So some development is linear, some is quadratic, which means like there are kind of stagnant rates and then accelerated rates, and some experience declines. And kind of alluding to our last bullet point, it involves both gains and losses. Young does not equal gain, old does not equal loss, can occur jointly. So one kind of example is, this is a classic test on the screen right here, is a Stroop task. And what you see here is that the words of colors are written in, but they are colored, they're filled with different colors. So yellow is written out and is filled with red ink. Well, children, once you reach a certain age, once they develop reading skills, they increasingly become more proficient at reading, because reading becomes more of an automatic process. You're not sounding out every letter, for example. Well, that obviously makes you a faster reader, right? Well, for these tasks, it actually makes you perform worse, especially for young children on this task, because they now are automatically reading the word, and they're not stopping. If I ask them, hey, what is the color of the word yellow? Or they would say, the word yellow instead of red, because they're automatically reading that word. So that's an example of a linear development in reading actually contributing to a decreasing ability to perform well on this task. So continue on. Historical and cultural context shapes development. A lot of textbooks do not emphasize culture, but especially not historical period. But I'm going to emphasize it a lot in this course because, I mean, Bolt's told us it's a great thing to do. Nature, nurture, interact, and development is best understood through interdisciplinary studies. Psychology, I always make this joke all the time, is literally like the study of anything. And then development is the study of anything progressing. So, political science, economics, sociology, psychology, geneticists. I've worked with anthropologists are all studying or have studied developmental psychology because it's so broad. The question is the study of change in human behavior, which is a gigantic field. And when you consider that all the environmental influences on development, then there's a lot of different approaches you can take to studying developmental psychology. The scientific method. What is it? Belief that investigators should allow their systematic observations to determine the merits of their thinking. Theory, a set of concepts and propositions intended to describe and explain certain phenomena. So colloquially, we use the word theory as kind of like a guess, or we kind of use it like hypothesis, but really a theory is this massive concept that contains multiple hypotheses that's been studied for and has support from hundreds, thousands of experiments. So continuing on that line, hypotheses are generated from theories. Good theories should be internally consistent, falsifiable, and supported by data. So falsifiable is kind of the one that you see violated pretty often. You can just say, okay, well, prove. You can make up any theory you want. You can say right now that I'm in fact a lizard man. I do have a green screen behind me. And maybe you accuse me of being a lizard man. Well, how can I disprove that? I can never falsify your theory. So a good scientific theory has to be falsifiable. I have to, through experimentation, be able to prove your theory wrong, or it's not a good theory. Okay, let's look at sample selection. Sample is a group of individuals studied. Random sample identifies all members of a larger population randomly selects. Goal is to have your sample represent the total population. So the idea here is that no study ever is going to collect data from all, whatever it is, 7 billion people. However, you can randomly sample particular populations which represent the larger global population. So whether that number is 100 people, 50 people, whatever, you can statistically calculate how many people you need for a valid sample, and that is how people do research. All right, we're going to look at 3 ways to collect data: verbal reports, behavioral observations, and physiological measurements. Okay, let's start with verbal reports. Ask questions about themselves or others. So this refers to interviews, written questionnaires, kind of achievement tests, personality tests, etc. So this, you can see these in BuzzFeed articles, as the article I pasted here, or you can see it in an IQ test. But there are limitations, and there's limitations to all these types of methods by which we collect data. Specifically from verbal reports for children, it's difficult at times. If you ask the children what their personality is, they'll often have a difficult time fully articulating that point. Same thing with a cognitively impaired population. If there are numerous historical examples of people with sustained serious brain injuries, and they're unable to provide accurate feedback of their day, of their past, their recent past, or their distant past. And social desirability. So if I feel like you want me to respond to this moral question, this moral dilemma about stealing, I want you to think that I'm not a thief because that's what you want. Whatever. I I know that you desire for me to not be a thief, so I will lie and say I'm not a thief, and then that'll screw up your data. So let's look at behavioral observations, specifically structured observations. They create special stimuli tasks or situations designed to elicit behavior of interest. The strength is that they achieve greater control over the conditions, and the limitations are how natural/real is this. So the idea here is that you put a child, a adult, whoever, some human or animal, in a specific room where you're controlling all the environment. There's no outside noise, there's no people walking in. You are design that room so that they are only exposed to the exact stimuli that you want them as a researcher to be exposed to. So it's great. You have great control over the condition. You can accurately measure a specific condition, a specific construct, whatever it is that you're measuring. Now, the limitation to this is generalizability. Is what is observed in your experimental context, is that valid in the real world, where all those other distractors that you got rid of actually exist? And that's a question. Now, looking at another aspect of behavioral observation, another type is naturalistic observation, which is observing people in the real world. The strength is you observe people in the real world, and the limitation is that behaviors can be random or rare. So this kind of gets at what happens in the real world. You're able to see how people are actually living their lives. So it may be a more accurate representation of who they are. But if I'm trying to observe a specific behavior, so I'm really interested in like teens smoking, but for some reason I decided I'm going to try and collect that data from Barnes and Noble. Well, it's going to be kind of rare there, right? It's going to be a difficult place to collect that data, even though teens are at Barnes and Noble. So some behaviors are rare in certain contexts, and they're just rare, period. And it's also random. So sometimes who knows whatever's happening in that teen's life that day. They don't feel like smoking or they feel like smoking more. So there's all these other variables that you aren't controlling for. So you get to see them in the real world, but there's a lot of other things going on, and you cannot be sure if whatever it is that you're interested in that's driving smoking is what's actually driving smoking in that context because of the amount of environmental factors that are not under your control. So moving on to another component of data collection, that's physiological measurements, neurological activity, genetic expression, heart rate, stress hormones in the blood. One technique is fMRI studies, which measures the blood flow to certain areas in the brain when the brain area is active during an administrative task. So let's say I put you in an fMRI machine and I give you a theory of mind task, which I'll cover in later slides and other chapters. But the point is, I'm giving you a psychological test, and then I can see what parts of your brain are being activated during that task. Well, so that kind of gives neurological evidence for that brain region theoretically or brain system being theoretically implicated in performing that task. Now, the limitation is what exactly is being measured. So the idea here is that brain region, what came first? Was it that that brain region increased the ability to perform on that theory of mind task, or was performing theory of mind tasks in the real world, kind of strengthening those neural connections that is evident within the fMRI results that you find? Case studies, what is this? This is an in-depth examination of an individual or a small number of individuals. It can provide a rich picture of atypical development. Findings can be used to generate hypotheses for future large studies. Again, the limitation is generalization questions. So in this case, this is generally seen for either behavioral therapists will use this or individuals with a very rare disease, or something really kind of uncommon that someone's interested in. So you'll follow these people for years. It's kind of similar to a longitudinal study, which we'll get to, but you're just following the small groups of individuals for a very long time. So you're getting a lot of data on atypical development, but are your findings generalizable to outside of your case study? Oh, good timing, bitch. So let's look at experimental methods. Experimental method, an investigator manipulates some aspect of the environment to see how this affects the behavior of a sample of individual studies. Independent variables that is manipulated by the researcher so that its causal effect can be assessed, and a DV is the variable expected to be affected. Okay, in English, that is, so say hypothetically I'm interested in if a certain medication, some kind of pill, reduces cholesterol levels in an individual. So what I do is I give one group of people who are randomly sampled my new magic anti-cholesterol pill. So I give one group my new pill, and I give another group the old whatever the standard cholesterol pill is. So pill B, we'll call that. And then I can give another control group no pills. So what I'm doing is I'm manipulating the administration of that cholesterol pill. That is my IV. My DV, my dependent variable, it's literally dependent on the manipulation of my IV. That's a variable expected to be affected. So what is my DV in this case? Cholesterol levels. I'm manipulating the IV, again, the cholesterol pills, to see if it's the extent to which it impacts my DV, which is cholesterol levels within an individual. Three critical features: random assignment, manipulation of IV, experimental control, can control other groups, which I just explained, can infer that one thing causes the other, limitation, generalization to the real world, sometimes impossible to conduct studies. So kind of the big takeaway here is, yes, this is a good method, and that works well in that cholesterol sample, like semi-well. There are still issues with that as well. But for example, my research looks at the impacts of big national traumas on the population. So can I, and specifically war, specifically natural disasters, specifically some kind of economic policies. So I cannot ethically invade my hometown Daytona Beach with a guerrilla movement and occupy that area to see what the impact of a military occupation would be on the city of Daytona Beach. It's unethical. It's impossible to conduct. So while that method of experimental control is very valid, measuring complex social phenomenon is basically impossible to conduct and control for in a actual experiment. So because of that, researchers look at correlational studies. This determines whether two or more variables are related in a systematic way. There's no random assignment of individuals, so AKA I can't expose some parts of Daytona to a military occupation and other parts not. There's no random assignment or manipulation of my IV, which in that case would be a military occupation. However, once correlation study is complete, you have something called a correlation coefficient, which is the index of the strength of the variables between two variables of interest. It ranges from +1 to -1, with +1 being a perfect positive relationship and -1 being a perfect negative relationship. So let's look at example. Is a child born underweight associated with behavioral problems in preschool? Okay, so we're going to look at the top left first, a negative correlation. So let's look at the axis. That's the birth weight. So you can see it's going from 0 to 16, we'll call it pounds, doesn't matter. And then the y-axis, the vertical axis, pre-K behavioral problems. So again, going from 0 to 16, I just made this up. All these are made up by me in SPSS. So the more problems there are, the higher you are on the scale. So look at 0 birth weight, or whatever that is, 1 pound. 1 pound would be associated with about 15 behavioral problems, and go all the way to the end. 10 pounds would be associated with 6 behavioral problems. So you see that downward slope? That's a negative correlation. As one of your variables go up, that is, in this case, birth weight, your other variable goes down. That is, in this case, pre-K behavioral problems. Now, let's look at the bottom figure, where a positive correlation R equals 1. So the same scales, but this time, let's look at 2 pounds. This time, 2 pounds is associated with 2 behavioral problems. 10 pounds is associated with, I think that's 10 behavioral problems. And then we have 15, which is associated with 15 behavioral problems. So that upward slope. In this case, as birth weight goes up, pre-K behavioral problems go up as well. And then we have no correlation on the right-hand side, which is no correlation, R equals 0. It's kind of hard to make it. That's actually not R equals 0, but it's close enough for purpose of this. So those are our 3 examples. Now, correlation coefficients are never R equals 1 or R equals -1 because there are so many other variables that affect an outcome. So it ranges between 0 and 1 or 0 and -1. And then there are ways statistically to kind of test the strength, how strong that correlation is. There's certain heuristics, so strong, weak, moderately strong, etc. So limitations of correlation research, rival interpretations. So directionality problem, direction of the cause and effect. So no one is control because you're not manipulating an IV, you don't know what's coming first. So for example, if a child is being annoying, and the parent is bad. The parent is performing whatever, bad parenting or something, poor parenting and poor child behavior. Which came first? Was it poor behavior by the child, or was it poor parenting that led to the poor behavior by the child? So we don't know. The effect of the relationship could be either or. There's also a third variable problem. The association between two variables of interest may be caused by some third variable. So say the child, again, we have a child as being an annoying variable and a parent is, a poor parenting variable. Well, what if what is actually causing both those variables, the fact that that the parent is making $10,000 a year? So maybe it's an economic factor explaining both of those problems. So it's a third unmeasured variable actually causing the relationship between your two original variables of interest. So moving on to meta-analysis. An issue within psychology research, and I should say in other fields as well, is a replication crisis. So just because one researcher finds a study at a specific time within a particular sample does not mean that those findings are consistent across all future studies. So one way to look at kind of analyze this is through a meta-analysis. It's the results of multiple studies addressing the same question, synthesized to produce overall conclusions, aids in the confidence of research findings. So what these researchers do is they literally put out calls and email all these researchers. I get these emails and they say, if you have any research related to a specific topic, send it my way. But typically they also look at already published studies. So they'll go through all the studies related to a specific topic. So for example, birth weight, and they'll do all kinds of very complex statistical analysis. And then they'll say, okay, birth weight, based on all these studies, we believe the birth weight has X correlation coefficient, for example. So let's walk through one. Birth weight and mortality in adulthood. So the impact or the predictive nature of birth weight on mortality in adulthood. We retrieved 22 studies. These results show an inverse but moderate association. So actually, look how much you already know here. An inverse means negative correlation, but it's moderate. So I don't know, whatever a moderate R would be. So I'll just make up a number, R 0.3. But however, for men, higher birth weight was strongly associated with increased risk of cancer death. So that's a positive correlation and it's strong. So we'll just say 0.6 correlation coefficient. And you can see a figure from the article here. Now let's look at some cross-sectional studies. What is a cross-sectional design? Different groups are compared. One type of group is age, provides information about age differences, measuring the effect of age on outcome variable. Cohort effects, effects of being born as a member of a particular generation. All right, so the idea here is a cross-sectional study is basically one-time collection of data. So you're coming into a lab one time, I'm administering some kind of task, and say I want to measure how good you are at using discourse or I don't know, Twitch, based on, and then compare your performance on Twitch or discourse across age groups. So 50-year-olds and 20-year-olds, who performs best on Twitch? Who knows what they're doing? Well, based on those findings, you can conclude that, oh, okay, well, 50-year-olds suck at using Twitch and 20-year-olds are just awesome. You're awesome at using Twitch. Now, what's one limitation for that? One is cohort effects. So it may be that no, there's not just some innate developmental process wherein older adults are unable to use technology at 50 years old. It's just that from birth to 20 years old, these 20-year-olds were on using the internet. So this is kind of second nature for them, while older adults had to learn it, when they were 45 years old, 50 years old, whatever. So that's a cohort effect. actually driving the differences between performance on Twitch or Discourse, whatever, Discord. So kind of a term for that is being confounded. Focuses on differences between groups, inter, not change within groups. So the idea here is we're comparing two groups. It's inter differences, not intra. It's quicker and cheaper than longitudinal studies. So despite those limitations, they are quick and they're easy to use. So we are going to keep using them. So let's look at another type of study, which is a longitudinal study. One cohort of individuals assessed repeatedly over time, traces changes in individuals as they age. So this is similar actually to a case study, but you basically have a much larger population. Like you often find hundreds, thousands of people in these kind of studies. They're looking at intra change, not inter. So they're looking at change within an individual because they're following individuals throughout their development. There are some studies that actually look at inter as well, but that's besides the point. For this, it's fine. They're looking at intra change. So some limitations, let's look at some strengths and weaknesses. They can indicate whether characteristics and behaviors measured remain consistent over time, can early life experience. So if you follow someone for 40 years in this research study, you can look at specific events that happen to those children and see if it's correlated or associated with or predictive of certain adult outcomes. Where limitation, age effects and time of measure effects are confounded. So say you're collecting data. So say I have a longitudinal study and we're at year, we've been following newborn babies for the last 6 years or, whatever, 5, 6 years, doesn't matter. And then all of a sudden COVID happens. Okay, so now we have this new gigantic environmental factor. So that is obviously going to affect the development of our sample. So that changes the conclusions of our study. So was it the things that happened to the child at, whatever, at 1 month old that's predicting this 6 month old behavior, or is it now a year of COVID quarantine? So these big events can you kind of throw off interpretations of your data. It takes a lot of time, costs a lot of money, participants' retention rate, testing effects. So basically here is that over time, the more time that you have longitudinal studies, the more people stop showing up, which can screw up your data because people who are most at risk and who are kind of most interesting, they're more likely to drop out and can screw up your sample. And if it's a testing effect, so if you're administering the same test over and over again, is it that people are developing, are showing some kind of development, or is it that they just memorize whatever test it is that you're administering? So let's look at our last kind of design. This sequential design combines cross-cultural and longitudinal. So you can see here on the right-hand side, you basically have one cohort, say that you collect a bunch of 20-year-olds in 2010. Then at 2040, you collect a second cohort, which is cohort B, while still collecting data on that original cohort. And then 2070, you're collecting, you add another cohort and you're still collecting data on the original two cohorts. I've actually participated in a study like this, and I still am in the Congo, and it's very challenging, costs a lot of money, and it's very complex statistically. So, conducting culturally sensitive research. 2/3 of research published in American journals were American. Approximately 95% of the world were not US citizens. Weird population, how generalizable are psychology's findings. So the idea here is if 95% of the world is not US citizens, and I know from other studies that the super majority of research is coming out of US and other kind of industrial Western European states, are the findings that we are finding, are they generalizable to the rest of the world population? I don't know. And you'll see throughout this class that some things that have been thought to be subtle science, once they are measured in other populations, uh, reveal that it is anything but subtle science, and the original interpretation was incorrect. And weird stands for uh, white. And weird stands for white, educated, industrial, rich, democratic. And even in that acronym, you can see kind of a little bias. So what is democracy? Is it, the specific, being able to yell fire on a plane? Is it being able to scream on campus about God knows what? Or is it about, whatever, free housing? In some, cultures in economic systems, political systems believe it's both. So, even within that, there's a lot of assumptions. So cross-cultural research requires procedures are meaningful in each culture and mean the same thing across different subcultures. So anybody that speaks multiple languages understand this. So when you're trying to translate something, it's not exactly the same. So when you do research, it's not only that you have to translate something into a new language, you have to ask yourself, does this concept even is it even culturally relevant? Does it mean the same thing? And then what you have to do is then back translate it back to English and then see how accurate and how similar your new back translation is from your original document. Another process that I had to go through a lot of times in the Congo, and it's quite challenging to do. So to work their own, so to keep their own cultural values, revising their own perception, difference within groups, different versus deficient. So two concepts here. One, there's not just like one culture. There are obviously differences within a group. Should be straightforward. And different versus deficient. So is it that just because one group performs better on a specific task that American universities have designed, does that mean that they're deficient like globally? What does that exactly mean? And would a psychological test designed by a different culture, which maybe Americans perform bad at, I think we would be much more quick to say, oh, we're not deficient, we're different. So those are just some questions to keep in mind. So let's look at some rights here. Let's talk about the rights of participants. So basically, anytime you want to do an experiment, you have to submit your experimental idea to the IRB, which is an institutional review board, and they review and either approve, disapprove, or kind of approve with certain conditions. Your your experiment. So you're asking, can I run this experiment? And if they disapprove of it because it's too dangerous, say I want to do an experiment. Oh, what would happen um, if I randomly pulled the fire alarm? I don't know, in a nursing home or something. So, could be interesting, also incredibly dangerous, and probably not going to get a lot of great data out of that. And the IRB would say, you cannot do that. So informed consent must be voluntary, obtained at least dissent or agreement, must not be pressured to use it. So basically the key takeaways here is that you get consent, but just because you have consent in the beginning of the experiment does not mean that, okay, this person is locked into your experiment. They can leave anytime they want and have certain rights after the experiment, which would we get into debriefing, which explains the study to participants afterwards if information was withheld or deceitful. So if I wanted to trick you because I feel like you knowing the true reason for this experiment would screw up my results, then maybe I lied to you a little bit. But at the end, I'm required to tell you why it is I lied to you, what the experiment's really about, and provide contact information, obligation to make sure the participants would not be exploited. So that's the end for this week. I hope you enjoyed it. I'm excited to be being your professor this semester. If you have any questions, reach out to me, and I look forward to a great semester. Thanks, everyone. See you next week.